Hi, I'm Fishing Paul and welcome to the Advanced Control tutorial. This tutorial is part of my Advanced QMD tutorial series where I deal with more advanced concepts of QMD so you can make the most out of your QMD experience. All tutorials in this series assume you have watched the basic tutorial series and/or are familiar with QMD in general. In this tutorial, I'll show how we can exploit Redstone and OpenComputers to finally control our accelerator multiblocks and then apply these lessons into a multifunctional setup. We can use Redstone to better control our accelerators in two ways. One is to change the output energy of the beam, and the other is to change the beam's entrance and exit ports. Now, when an accelerator receives a redstone signal, this will change the beam's output energy depending on the strength of the signal received. And in fact, there is a linear relationship between the signal and the output energy. In a knock, the output energy is simply equal to the input energy plus the absolute charge times the voltage times the signal strength divided by 15. In a synchrotron, the output energy is equal to the minimum of the dipole field strength and synchrotron radiation energy equations times the signal strength divided by 15. And in a decelerator, the output energy is equal to the dipole field strength energy times 1 minus the signal strength divided by 15. The other use of Redstone, as we said, is to change the beam's input and output ports. You can install multiple ports in an accelerator, but only one input and only one output may be active at a time, with the exception, of course, of the beam splitter, which has one input and two outputs. And our ports can be shift right-clicked with the multitool to set their redstone mode, which is what mode, either input or output, they will switch to if given a redstone signal. So, what might be the use case of redstone here? The answer is a multifunctional setup. We can perform multiple recipes with one set of multiblocks, greatly saving on material costs, space, and operational costs. For example, let's take a look at the light fission waste recipe and the spallation to pions recipe. Light fission waste, as we can see, takes place between 100 to 600 mega electron volts, but spallation to pions seems to take place between 600 mega electron volts to 5 giga electron volts. This is a problem. There is no overlap in the energy range of the two recipes, but by setting the redstone signal strength and thus the beam energy with one synchrotron, we can do both of these recipes. For example, we can just design a synchrotron with a maximum energy of 1 gigaelectron volt, and then with a single strength of 3 corresponding to 20% of the maximum energy, we get particles that go at 200 megaelectron volts. We can also set up two output ports so that the two recipes can be done in different target chambers. Of course, we don't need to do them in different target chambers, but for the purposes of this video, I will do the two recipes in two different target chambers. So of course, I can just use the multitool here. By shift right clicking on a port, I can just click the port to set the redstone setting. When it receives redstone, what mode it will turn to. Now this port will turn into an output port when it gets a redstone signal, and same thing goes for this port. To perform this entire functionality, I made this control panel here, and also all this redstone circuitry going around the accelerator. Let's now turn on the accelerator. And now the accelerator is working in fission mode, producing 220 megaelectron volt particles, which go into this target chamber. And then by flicking this lever, it now works in spallation mode, producing particles at 1.03 gigaelectron volt. And here it can perform spallation to pions. Of course, looking at the circuitry and this control panel and everything, one might have the question, well, this is clunky, surely there is a better way to achieve this, right? And the answer is yes, dear viewer, there is a better way, and it's called OpenComputers. QMD offers extensive integration for its accelerators with OpenComputers, including methods to retrieve information about the accelerator and methods to set properties of the accelerator. You can find a list of all the methods in QMD's wiki, but in this video we'll stick exclusively to 3 set methods, which we'll use to simulate the redstone control used in the previous chapter. So first, to establish an interface between OpenComputers and the accelerator, we need this block right here, the accelerator computer port. You place that in the casing, and then you just connect the computer directly or via cable to this port, and the port and the computer can now communicate. So we have 3 methods we're going to use in this example. First method is set computer controlled. It takes a boolean, true or false, as its argument. makes the accelerator controlled either by the computer or by redstone signals. Set energy percentage takes a number that's either 0 or between 5 and 100 in increments of 1. This number is turned into a percentage and is substituted for the signal strength divided by 15 term in the energy equation. For example, set energy percentage 35 means that for synchrotron, the output energy is 35% times the minimum of dipole field strength and synchrotron radiation. And finally, switch beam port, which takes x, y, and z coordinates. If there is a beam port at these coordinates, it switches to whatever mode it is set to switch to if it were to receive a redstone signal. It is therefore extremely important to set the beam port's redstone mode before running this method to prevent any unwanted surprises. So I've prepared a little script. This is the script, which performs in a few lines of code all of the functionality that we used to get with redstone. First, we import the required libraries, we set the accelerator as a component variable, and then we also have this mode variable here, which is an argument variable. So whenever I run my script, I can attach a word, and that word will be taken as the mode argument, and depending on what the mode argument is, it will set the actual profile of the accelerator. Then we use the setComputerControlled method so that the accelerator completely ignores redstone signals, and then we've got the setMode function, which takes the mode argument that we input when we want to run the function. And so Fission sets the accelerator's energy percentage to 20, so that the accelerator will run at 20% of its maximum energy. And the beam port at these coordinates, which corresponds to the beam port which goes out to the target chamber which performs the fission recipe, that port will be switched into output mode. Then if we say spallation as our argument, it will set the accelerator energy percentage to max, and it will switch the beam port at the spallation beam port coordinates to be output. And finally, if we say off, then it turns off the accelerator. Then we just run the function, and that's it. Let's demonstrate this in action. Fission. The accelerator is now on. It's running at 220 megaelectron volts, and the fission waste target chamber is on. Then we can simply say spallation instead. And now the spallation target chamber is on. The protons are output at 1.1 gigaelectron volts. And finally, we can say accelerator off. And the accelerator has turned completely off. And thus, in just 3 blocks, we have achieved the same result as we did with redstone. Let's now go to the lesson recap. And that marks the end of the tutorial. I hope that now you know how to use Redstone and OpenComputers to make the most out of your accelerators, and that you found this tutorial useful. If you have any topics you want covered in an advanced tutorial, let me know in the comments. See you in the next video. Goodbye.